Goliath Tracked Mine. The Goliath was small enough to be mistaken for a toy, and lethal enough that Allied troops learned to fear it the moment they recognized the silhouette. A miniature Remitech-controlled tracked vehicle roughly the size of a large suitcase. It carried up to 100 kilograms of explosives and was steered toward its target, a tank, a bunker, a bridge support via a long trailing cable connected to a control box in the operator's hands. Once positioned, the operator detonated it remotely, destroying the Goliath along with whatever it had reached. Germany built thousands of them, and on paper, the concept was elegant, a disposable robot soldier that never had to be replaced with a human life. In practice, the slow speed, thin armor, and vulnerability of the trailing control cable meant Allied troops frequently disabled a Goliath by simply shooting the wire before it arrived. It remains one of the earliest combat deployments of a Remitech-controlled weapon in history, a rough mechanical ancestor of the guided munitions that followed it. Sundercraft Farzo 2, the Kettenkrad looks like two separate vehicles that lost an argument about which one to finish building. A motorcycle front end fused to a small tracked rear end, steered by handlebars but driven forward by rubber tracks rather than a wheel. Germany built it to solve a specific problem, being towed behind transport aircraft as portable ground support once German paratroopers landed. Its tracked rear gave it far better traction and ground clearance than any motorcycle, while the handlebar steering kept it light and simple to operate. It served through the entire war on multiple fronts, prized for going places nothing else in the motor pool could reach, and after the war, several were repurposed for agricultural work, a piece of military engineering quietly finishing its service life, pulling a plow. Schienenzeppelin, like Object 279, this one comes with a timeline correction attached. The Schienenzeppelin was built in 1929 and set its speed record in 1931, years before the war began, and it was scrapped in 1939 for its aluminum before the fighting even started. It earns its place on any strangest vehicles list regardless because nothing else built for German railways looked remotely like it. A sleek aluminum skinned rail car powered not by a locomotive engine but by an aircraft engine and a rear-mounted wooden propeller borrowed directly from aviation design. It reached 230 kilometers per hour on a test run between Berlin and Hamburg, a rail speed record that stood for over 2 decades. The exposed propeller was also its downfall. A spinning blade at head height on a crowded station platform was too dangerous to put into passenger service, and the design was abandoned before it ever carried the public. Its aluminum was melted down for wartime production, a peacetime engineering marvel recycled into the war it never actually served in. Bakum 349 Natter. Germany built the Natter for a single brutally simple mission: launch vertically straight up like a rocket, climb fast enough to reach a bomber formation before it could pass overhead, fire a volley of unguided rockets into the formation, then have the pilot parachute out while the airframe itself broke apart and fell separately. Its rocket motor recovered and reused. It required no runway since it launched straight up from a vertical rail using solid rocket boosters strapped to a rocket-powered fuselage. It was by design closer to a manned, reusable anti-aircraft missile than a conventional aircraft. Its only manned test flight ended in the pilot's death when the canopy detached during ascent. The war ended before it saw genuine combat use, leaving the Natter as one of the most extreme expressions of a very real Luftwaffe problem: Allied bomber formations that conventional fighters were running out of time and fuel to intercept. Folly a Gallus F330. The FA330 had no engine at all. It was an unpowered rotor kite towed on a long cable behind a surfaced German U-boat. Its rotor blades spinning freely in the airflow generated by the submarine's forward motion and lifting a single observer high enough up to 150 meters above the water to see far beyond the horizon, visible from the U-boat's own conning tower in the vast empty stretches of open ocean, where a single spotted convoy could mean the difference between a successful patrol and a wasted one. That extra altitude and visibility was valuable enough to justify towing a fragile, unpowered aircraft behind a submarine that needed to be able to crash dive at a moment's notice. If a threat appeared, the observer had to disconnect, glide down, down and get the folded kite back into its watertight deck locker fast enough for the U-boat to submerge. Hafner Rotabuggy. Britain needed a way to deliver a jeep by air directly into a landing zone without a runway, a parachute drop rough enough to damage the vehicle, or a glider large enough to be a scarce and valuable resource. The Rotabuggy was the answer. A standard British military jeep with an unpowered rotor and tail assembly bolted directly onto the vehicle itself, towed into the air behind another aircraft like a glider, released and auto-rotated down to land on its own wheels, ready to drive the moment it touched ground. It flew successfully in testing, reaching speeds over 100 kilometers per hour under tow with the rotor spinning freely above it. The concept worked. It was never adopted operationally. By the time testing proved it viable, other delivery methods had already solved the same problem with less mechanical complexity. Mistel Composite Aircraft. The Mistel was two aircraft flown as one. A large obsolete bomber airframe, typically a Junkers WW8, had its cockpit removed and its fuselage packed instead with a massive explosive charge, converting the entire aircraft into a guided bomb. A smaller fighter aircraft was mounted on struts directly above it, its pilot flying the combined assembly toward the target, aiming the lower aircraft using the upper one's controls, then releasing the explosive-laden bomber to glide the rest of the way into whatever it was aimed at, while the fighter above broke away and returned to base. It let Germany turn aircraft too old and too vulnerable for conventional missions, flying pancake. The V-173 looked less like an airplane than a flying discus. Its entire fuselage built as a nearly circular wing, with two enormous propellers mounted near its wingtips. The shape was not a stunt. American engineers were testing whether an extremely low aspect ratio wing could generate enough lift at very low speeds to allow an aircraft exceptionally short takeoff and landing distances, ideal for operating off small aircraft carrier decks. It flew successfully, and pilots who tested it reported it was remarkably stable and difficult to stall even at very low air speeds, exactly as the unusual wing shape had promised. It never entered production. By the time testing concluded, jet propulsion was reshaping naval aviation faster than the propeller-driven pancake concept could keep pace with, but it proved a genuinely radical wing shape could fly safely, a fact confirmed by a machine that still looks more like a prop from a 1950s science fiction film than a wartime aircraft. Bloemann Voss BV-141. Most aircraft are built symmetrically because asymmetry usually means instability. The BV-141 was deliberately permanently lopsided, a single engine and tail boom mounted on one side of the aircraft. The design gave the observer in the glazed pod an unobstructed view in almost every direction. German test pilots found it flew better than its bizarre silhouette suggested. The asymmetric design compensated for carefully enough in the airframe's construction that it handled predictably despite looking like it shouldn't. It never entered mass production.